Okay, so welcome. My name is Anita Manuel. I am the Associate Director for the Career Center here on campus, and very excited to be able to co-host this event with you today and share some information on majors and careers in analytics. We will be co-hosting this event with a team from academic advising. And so the goal for today is to really give you an introduction into the various career paths that one can pursue with data analytics. And I will be giving just a quick overview of some ideas that you can think about, as well as some tips that can help you with your career exploration. And then we will have time for the main part of our event, which will be a panel from the various departments on campus that offer analytics related programs, majors and specialties. If you are joining us, we will be posting a Google form check-in, so that will be in the chat. And if you click on that and fill it out really quickly, we'll just know where to send a copy of the recording if you'd like the recording of today's webinar. Also, if you have questions either for myself or the panelists when they're speaking, please post them in the Q&A. So instead of chat, please use Q&A for questions for the panelists. We do have some of our colleagues on the back end who can answer some of those questions, but also share those questions with the panelists. And I think we are ready to begin. So our featured panel, just so you know who will be represented today, our esteemed faculty from the following colleges. We have representation from the College of Business, College of Professional and Global Education and Science, Social Science, and then College of Health and Human Sciences. And then at the end of the panel, we'll have time for student Q&A, and you can go ahead and make sure that you post those questions in the Q&A box. So before we get in too deep, I just wanted to review a couple ideas. And one of the most common questions that we get in the Career Center is, I've heard about analytics or data analytics, but I'm not sure what data analytics actually means as a field. So first and foremost, what we're talking about today is the process of using mathematical models to collect and analyze data, develop insights, and then share outcomes or narratives using visualization to help inform decision making. And so the way that that looks is you're going to have some sort of problem. Analytics is used across various industries, as we'll learn today, that you're trying to solve. You're trying to find the right information and data to solve that problem. And now with, the internet and social media and so many different ways of creating data points, you have to figure out how to collect data at scale, analyze that data at scale, and then share those insights with people who might have to make some decisions about those various problems that you started with. So we do use data analytics every day. So some good examples are when you check the Santa Clara County COVID-19 case analytics dashboard and you want to know exactly what's going on with health and wellness within our community. This is a good example of using data analytics on a daily basis. Also, if you think about your daily consumption of media and how it's become more and more personalized and targeted to you based on your preferences. So last time that you checked into Netflix and were looking for something good to binge on, and it was giving you recommendations of things that you might like, that was all based on collection and analysis of data and information at scale. A lot of different industries are also using data analytics to solve big problems, right? So it's not just making sure that we can provide you with your preferences as it relates to, food recommendations or media consumption, but also in health and wellness. So this is an example of how analytics was used to actually develop cancer cures. So this is Harrison McKinnon, 10 years old when he was diagnosed with acute lymphoma, leukemia, and probably the most common type of childhood cancer. And after 2 weeks of intense chemotherapy, actually suffered a life-threatening seizure. And so it could not continue to use what was maybe the common type of approach to dealing with cancer in children. And so, you know, these scientists use data analytics to analyze his genetics and see if there might be other ways to create a therapeutic that would be helpful for this particular individual. The importance of data analytics is that it allows researchers to identify reasons why kids like Harrison don't respond to standard therapy. And this is stated by his father. The answer is in the data somewhere, and analytics helps researchers find the answers and in time to solve this problem to save Harrison's life, right? So looking at data, vast amount of data to solve really complicated puzzles is really what the field of analytics is offering, you know, people the ability to do. It's also big in sports too. So, you know, if you're thinking about other ways and other fields you might want to use to develop that career in analytics. NBA has really, and baseball too, most sports statistics are looking at ways to collect valuable data at scale, organize it, predict some outcomes, and then share it at scale. So now there's these sports VU cameras in every arena. So they're actually video collecting images of teams, players, shooting charts, lines up combinations, and then looking at that play-by-play video, categorizing it so that people can actually do real-time analytics of their favorite players and determine what they think are, you know, the strongest players. And of course, that can also lead to a lot of gaming and picking, you know, who you think your top players are going to be for any of your upcoming March Madness needs. The benefits of big data are obviously big to business as well, right? So the more that you can identify and use data to actually predict or have foresight of what might happen, the more you're able to increase basically your business models and revenues. So companies in the top third of their industry who are using data-driven decision-making were actually on average 5% more productive and 6% more profitable than their competitors. So if you're going in any line of business, having some understanding of analytics and data and using that for decision-making is going to be really helpful for you. So what do these actual job titles look like? Because it is a very broad field. So you'll see in this chart that there is a listing of the actual frameworks. So like there are people who actually have to make decisions. So they're called data-driven decision makers. So they need to know outcomes, but may not necessarily create or develop the algorithms or the methods of determining how the data is used, just using the outcomes to make decisions, all the way up to the actual people that are doing the hard sciences and crunching the numbers and developing the analytical frameworks to actually get the data that decision makers need. So you can see that some of the sample job titles would be like a marketing manager, an IT manager, makes decisions, but may not necessarily be doing the analytics. Next level up is called a functional analyst, and that's your business analyst, financial analyst. And that's kind of the more entry level type of position that you might see posted as it relates to data analytics. And then the more rigor that you will have to have in analytics training, whether that's coding, machine learning, or also the ability to do some visualization and predictions, gets harder as you get to the top of the food chain, where it's data scientists, economists, so professionals that are pursuing their PhDs in areas where they're specializing in using data and predictive modeling. The other reason this is really important is because there's a lot of job growth within these industries. So as you can see in this chart, the most common hires were actually going to be in this area of business analysts. So if you're looking for where there might be the most growth, the red circle that you see there are job titles that would be growing most quickly based on how many times they've been posted in job descriptions. And then on the left-hand side, you're going to see positions that are really fast-growing occupations, but maybe harder to fill. And there might be less opportunities for them, but they are going to be the most sought after. So data scientists and data engineers have the most potential growth at this point in time, with a look at what's posted now across various industries for job requirements. The other thing for focus on just a functional analyst and what that means, since it's the most entry-level type of data analytics position, is what areas or what titles do those cover? So actuaries, business management analyst, compensation and benefits, financial analyst, geographer or GIS specialist, human resources information system analyst, operations analyst, or research associate. These are common titles that you're going to see if you're looking at positions either in Handshake or on a job board or on LinkedIn that are really related to more of the entry-level areas of data analytics. The other image here is actually a data analytics team. So you can see that their specialties are across disciplines. And this team is actively hiring for new data scientists because their data team is growing so rapidly. And I don't know if you can maybe type in the chat, who do you think this company is that is hiring all these data analysts from anywhere from physics, electrical engineering, cognitive scientists, neuroscientists, all doing analytics? I'm going to check the chat really quickly. Okay. One person says it's Google. Any other guesses as to which company this is? Okay, Apple, another Google, SpaceX. That's a good guess. Okay, so these are all good guesses. Retailer stores. Okay, let's find out who this is that's actively hiring. It's actually the New York Times data science team. So if you think about marketing and advertising and how much traditional journalism has actually relied on marketing in a traditional sense and knowing how to best connect with their readers, publishers are now putting so much resources into the ability to connect with people online and understand how they are digesting their media and information. So this is the New York Times data science team, and they are hiring. The other thing is the current data scientist from Airbnb was quoted as saying that their team is actually made up of people who have a background in computer science, engineering, statistics, economics, social sciences, and physical sciences. So every discipline area, as you're going to find out from the panel, has a need for data scientists. The other thing here I want to just highlight is if you look at job descriptions, there is not always a consistency with how people are titling positions for data. So it's either data analyst, data scientist, researcher, general analyst. So you really have to dig in deep with your research and read the job descriptions if you want to understand the specifics of what a certain organization is hiring for. So typically a data scientist has been thought of as maybe the higher level, more experienced, predictive type of role versus a data analyst that might be more of an entry level type of role. But as you do your research, you realize that different companies have different titles for their data teams. So this was an example of an article posted by a data scientist who actually does not have the title data scientists in their role at Google. So in Google, your title does not matter, your work does. So one of the questions that this particular person was getting is, you are data analysts, so why do you do machine learning? And so they actually, make a good point that you have to look beyond just titles to understand what's actually happening with the job that you might want to pursue. And then for skill sets, just realizing that a lot of times the focus is on the hard skills, so the statistics, the modeling, the coding, but also a lot of the data scientists who are successful are talking about ethical skills, this what we call the humanistic skills, being a team player, a lifelong learner, and communication skills as being very helpful to the role. And then if you're looking by pay scale and some of the research, and this was pulled from Burning Glass Technologies, so you can Google this as well. But basically, you can look at the highest demand technical skills and the salaries that are connected to that. So really, if you're looking at a broader range of what you can do with the career path, you have to also make sure you're doing your research. So as you research the field, I would encourage you to look at industry blogs and publications, as well as professional associations and meetups. This is a great blog that has had a lot of really helpful information called Towards Data Science. Here's a sample of the types of articles that they post, what no one will tell you about data science job applications, what you should put in your portfolio. So these are really helpful when you're researching the field. Key websites, job search sites that are just for data scientists, how to best find machine learning enthusiasts through meetups. So really good information as you research. LinkedIn is also a great resource for finding alumni who are already working the data analytics field. And then finally, how to build those skills. You'll learn more about that in the panel today, but just want to share that LinkedIn Learning is a resource that you have as a student. And this is an example of their whole data science collection. So you can actually take or do some of these on your own if you have some extra time and you want to learn some more skills. Definitely look for internships. There's currently 130 internships posted in Handshake, and they're all remote options. So you can work remotely. Employers that are posting, these are actually in Handshake. Facebook, as you can see, has one. New Relic, Netgear, eBay, KLA, and the San Francisco 49ers are currently looking for data analysts. And then finally, it's really going to be important to build a portfolio in this field. And so hackathons and projects or passion projects are going to be very helpful as you're looking at ways to develop your career. So I've seen lots of feedback from both employers and alumni on the importance of a portfolio in addition to your resume. So definitely getting things up on GitHub and also Kaggle are two resources that are really helpful for data analytics. And of course, you have campus programs that you have to take advantage of, which we're going to go into next. So there's a Data Science for All program that's open to all students. So you don't necessarily have to be in one of these majors to pursue this. And we also will have our esteemed panel that can talk much more directly to how their fields use data analytics and the ways that you can get connected with their programs. So at this point, I'm going to turn it over to Rima and to introduce our panelists.
Hello, everybody. So I am Primamali. I'm an academic advisor with AARS. I'm the lead advisor for all the undeclared students. And I'm hoping a lot of our students are here getting all this information. So our panelists from the College of Business, Dr. Mertz, if you could please introduce yourself and talk to us a little bit about yourself, your department.
Sure, yeah. Welcome also from my end to today's panel discussion. We are thrilled that you're interested in business analytics and that we are able to share some information about our concentrations or programs. So my name is Professor Michael Mertz, and I'm the chair of the Marketing and Business Analytics Department. Our business analytics concentration is fairly new, but it is one of the fastest growing concentrations in the university. And we already have over 250 students, and the concentration we have now for about 3 years. So if you decide to take our business analytics concentration, you're in very good company. Now, how does business analytics look from our perspective? Really, Anita has already done the major work and has answered all of those questions, but I want to just give it and emphasize that it's important for us from the College of Business. Our business analytics concentration is all about numbers, just as all the programs are. It is a quantitative approach to business. And what you will do is make intelligent use of data and apply mathematical models to form insights and make decisions that improve business performance. So that's the key of our program. We are really interested in applying all these tools and mathematical models to improve business performance. The nice thing about studying business analytics in our marketing and business analytics department in our Lucas College of Business is that your skills, as Anita already pointed out, are nowadays needed in nearly every function within a company, ranging from human resources to customer service, marketing, operations, and finance, just to name a few. So it is not surprising that your job prospects are terrific and that business analytics has emerged as one of the most lucrative career options in terms of salary and growth. And Anita pointed that out already. Our graduates typically end up in business analytics, so not the data science component that Anita pointed out earlier. Our graduates end up in business analytics or business intelligence or marketing intelligence or market research analyst or data analyst kind of jobs across different functions. So much to our concentration, and I hand it back to Rima.
Thank you, Dr. Mertz. I think we have a couple other folks from the College of Business, Dr. Marisa and Dr. Dar, if you want to speak a little bit about what you guys are doing with I think you guys have some seminars, right?
Yeah, I'm Professor Shubhankar Dar from the School of Information Systems and Technology in the College of Business. And we got an NSF grant, and this grant allows us to offer various seminars, data science seminars. For example, we offered, Professor Esperanza is offering Python, data science, Python programming for data scientists. I'm offering a course, a seminar. I've offered a seminar on statistical foundations of data science. And this semester I offered a seminar on introduction to machine learning on data science. And these seminars allow the students to take this, to learn about introductory concepts of data science. And after they complete these seminars, they can earn a digital badge by taking a self-assessment, quizzes, all these things. And these are free to all the SJSU students. So I highly encourage all the students to take advantage of this. It's a 3-hour seminar, and then there are some additional materials, post-seminar materials that are available to all the students, and they can take advantage of it. And no prior knowledge of data science is required to take this seminar. So we start from without expecting them to have any prior knowledge. So we so that's a very good, particularly those who are aspiring a career in data science, for data science. This is a good opportunity for them to get to learn about various opportunities in this area. And now, Professor Esperanza, you can also talk about your seminars.
Yeah, thank you, Dar. Yeah, as Professor Dar said, these seminars are designed for people who have no programming experience. So these are supposed to be seminars in which you can explore these concepts and without being afraid that you have never ever programmed before. So all of these seminars are standalone seminars. You don't have to take them all. You can take one or as many as you want to. And the idea is for you just to explore these concepts. Now, these data science for all seminars have been already 2 years. We are in our 3rd year, and then we're going to continue offering at least for 1 more year. I will post, I saw that there's a question in terms of where information about that. So after my presentation, I'm gonna just put the link there where we have the website, and that will give you then information about all of these seminars. Now, in terms of, I belong to the College of Business too. I'm in the Accounting and Finance department, and I'm faculty in the Accounting and Information Systems concentration. Now, all of the classes or all of the majors in the College of Business have some component of data analytics. In particular, the field in which I am, which is Accounting and Accounting Information Systems, we have just to transform all our curriculum to include the part of data analytics, because now you are not required only to be an accountant, but you are required to know how to use these particular tools. And just to give you some examples, we do for a classic examples in data analytics is how to identify fraud. So we do have in accounting different exercises in which we tell students how to gather this data and how we can analyze this data to identify fraud. But accounting and data analytics is not only about fraud, it can be also used for improving the efficiency of operations in a company. So for instance, companies use data analytics, mixing data from sensors. So for instance, some machines, when they are about to break down, they produce special noises. So we use special sensors to gather this information, and then data analytics to analyze when a machine is about to break down, so we can prevent that and then continue operating efficiently. So as you can see, if you are interested in data analytics, it's not necessary that you actually go hardcore and in the part of just knowing about data analytics, because right now all the College of Business majors, they have some component of data analytics to make you competitive in that area. So I will be hanging here out. So in case you have any more questions, then I will be happy to answer them.
Thank you, Dr. Huerta. So we will go next to the College of Health and Human Sciences. Dr. Dugan, if you would like to please explain briefly your department and what they do.
Yes, okay. Hello, everyone. Nice to see so many students interested in data analytics and careers related to data analytics. So my name is Dr. Dugan. I am the program coordinator for the undergraduate program in public health, and I am also the advisor for the population data science concentration. This concentration is actually fairly new. It just went into effect this fall because we realized the need for students leaving the workforce to understand data at a higher level than we currently provide them in our programs. And so I'm an epidemiologist and biostatistician by training. And basically what I do is understand the distribution of diseases in populations. So in epidemiology, we want to know who gets the disease, when they get it, why they get it, where they get it. Obviously, we're in the middle of a global pandemic right now, and there has never been a better time to be in public health and understand data as it relates to public health. Anita, as she was speaking just now, she showed the New York Times. You know, now they have a whole COVID-19 page and it's all over the news. And I'm sure you have come across as students plenty of data as relates to COVID. Anita also showed the Santa Clara County website, the cases and the distribution of COVID right here in our county. So this is a pretty important field, and in population data science, we teach you how to develop those skills. As you have probably noticed, looking at the data, some maps are better than others, some are more confusing, some are clear. And so in public health and in population data science, you will learn how to sort through all of these. As part of our exciting and innovative new curriculum, we are building on a lot of the theories that you will learn in the core course and looking at them, you know, from a more applied perspective. So you will be learning how to use tools like ArcGIS, you know, for public health, mapping things related to public health. So for instance, if you are interested in food and food systems, and people who are food insecure, you might need to do some mapping to figure out where all the food deserts are. So these are just some of the few applications that you can use to understand not only diseases, who gets diseases, but also hotspots, right? Where you can think of clusters of maybe food deserts or cancer clusters in the environmental public health field as well. So it's definitely really varied. The possibilities are literally endless, but what we are hoping to provide is a foundation for students so that they can enter into entry-level positions and then springboard from there, but they will already have the tools they need in the program. So as part of the concentration, we have 6 different courses, and the final of which is for students to develop a research proposal. But everything going into that, there's a whole course on data management and visualization. So, and you'll get to play with a lot of the more recent data management tools out there. Anita in her presentation showed a story about SAS, which is the widest used statistical software in public health. And last year we introduced it with our master's students, and our undergraduate students will be learning that as well. So we're definitely trying to make sure that once our students leave this program, they're equipped to succeed as public health data analytics leaders. So yeah, please, we're accepting applications at the end of December. So feel free to contact me, and I'm sure Christine Keller, who is our connection in career services, can provide you with my email address.
Thank you, Dr. Dugan. Moving on to the College of Social Science, Dr. Westlake, if you could please introduce yourself and your department.
Sure, thank you for having me. So my name is Dr. Bryce Westlake. I'm in the Department of Justice Studies, but more specifically in the Forensic Science program. So major shifts in information technology landscape over the last 2 decades have greatly increased the importance of proper collection and analysis of data, digital evidence. So basically every crime and every component of our life has a digital element to it. So this fall, we introduced a digital forensics concentration to our program. And so it melds mathematics, physics, computer science, criminology, and forensic science. And it focuses on analyzing digital evidence and drawing conclusions in a laboratory setting that is then used in criminal cases and in the court system. So with this type of program, you might think that people who are in this are going to be working for law enforcement. And while some of them do go that way, that's not entirely true. As has been outlined already, there's lots of places that use data analytics and people that are working with big data and digital data and all that kind of stuff. And so many of our graduates will go into large and small companies. A lot of the companies in the Bay Area and around the country have begun to have their own digital investigators because obviously they always have security cameras, or they have issues with fraud, or they have issues with sensitive data. So, you know, hospitals, for example. And then some, of course, will work with local, state, and national government, but there's a wide range of different opportunities there. And so in this program, students are provided with hands-on opportunities through internships that we're setting up with companies throughout the Bay Area. And then we also have a couple different research programs that are being conducted. So one is validating digital evidence software in different investigation styles and techniques and different types of data. As well as the development of a cybercrime unit, which will be able to assist on actual cases with investigators and working through the process of gathering data, analyzing it, writing out reports, and then presenting it. So if you're interested in this major, you can contact myself. If you want to declare the major, we have our window open right now until the end of the month. So you can declare your major through our application, and this can be found on the Justice Studies website. And on the top bar there, if you just go to for students and declare major, it'll be right there for you. Or like I said, you can just contact myself. I'm the one who's going to be managing the program. And so I can answer your questions and help with any of that information.
Thank you, Dr. Westlake. Dr. Holgen, would you like to talk about your department yourself?
Hi, thank you. It would be my pleasure. So has long been involved with analyzing data and applying that to decision making. And so I was really glad to hear Anita's presentation. And I think it was excellent. And also it's very interesting to hear how different programs on campus are adapting to the demand for workers with skills in this area. So in economics, as I said, we've been doing it for a long time, but it hasn't always been with large data sets. So one of the ways we've adapted is by teaching different types of software programs, including, we've taught Stata for a while, which is like SAS, as was mentioned earlier. But now we also teach R, and R is a free open source program. It has, in some cases, fewer limitations on data size. So that's one way. We also are involved with a minor program on campus. I'm not sure if we have a representative from it here, called ACBSS. That stands for Applied Computing for Behavioral and Social Science Students. And many of our majors take that as a minor, and that focuses on R programming and other things as well. So it was great to hear Anita talk about the importance of a portfolio. And I think if you are an econ major, you will have some projects and term papers that you could put in your portfolio. We recently created a new 2-course sequence in econometrics. And econometrics is a discipline, a subdiscipline of economics that basically applies statistical methods to economics problems. And so now we have a full 2-course sequence in that. And the second course serves as the capstone course for the BS program. And you'll write a term paper in there, and that would be great for your portfolio. So I think a student who is interested in any one of these analytics type careers could prepare themselves by taking the economics degree, specifically the BS degree. They were really sure that's what they wanted to do. In terms of the coding side of things, I would recommend adding a minor, the one that I mentioned, ACBSS. And I think that's about it. Oh, I guess I'll mention one last thing. I mentioned, the big data aspect of analytics and how we're trying to do more to prepare students for that. So I have a book coming out next year. It's called Data and the American Dream. And if you Google me or go to my website, mattholian.com, you can find the webpage for the book. And it talks about, in the book, it discusses a dozen economic studies, and they all have in common the use of the same data set, a data set called the American Community Survey, that every year surveys over 3 million Americans, and they do it every year. So since 2000. So there's literally millions and millions of observations. And I first started using it as a way to challenge students to push the limits of their computing abilities, even their computer hardware. Can you open up a massive data set like this and do some of the analysis that we've done in economics for a long time, but with a big data set, it's hard. And so this book is the result of that initial effort of mine to try to expose students to big data. And that's an example of the type of things you can do in economics. If you have more questions, please email me. We also have an undergraduate advisor. Her name is Ghislaine Lang. And we'd be happy to talk to you more about this. Thanks very much for organizing it. It's been a pleasure.
Thanks, Dr. Holgen. Moving on to the College of Science, we have Dr. Tortora and Dr. Mo here. So if you guys could please talk about your program and let the students know what they can expect and things like that.
Yeah, thank you, Rima. We have a new master that it's the first year that is just started in this fall, and is a master in data science. So I'm a statistician, and I'm in the mathematics and statistics department, and Teng Mo is from the CS department. And this program is actually hosted by both departments. So it's co-hosted. So as you can imagine, there is a CS component and an applied math and statistics component. So we are like, we're trying to form data scientists. So people that have a deeply understanding of the model, of the probability model, or the mathematics behind it, but also very strong coding skills. And so we just started, and as I said, the goal is like, so most of our students come from engineering or CS or math major, but we are open as long as they have a strong math background and a CS background to other students. We developed some new classes for this. So what you're going to learn is going to be technique for classification. So you are going to work with big amount of data. You're going to learn to analyze them with advanced technique to do prediction, to build modeling. It's basically, you're going to learn how to get information out of a big data set. And of course, this cannot happen without a strong CS knowledge. I'm sure Teng will follow up on the CS part more and more on the math part. And so the program is in 2 years, and it also involves project. So you will start with statistics and CS classes, and then in the second year you will be working with one of us for a 1 year long project in which you could work on real data, but we also do more of like research in sense of new techniques, so development of methodological development as well. So yeah, it's very exciting. We just started, and it's been interesting so far teaching those advanced class. I don't know if Teng Mo wants to add something.
Yes, thank you for Professor Totora's wonderful introduction. And I just probably have 2 more sentences to add. Like Anita has done an excellent job in the introduction. And this MS data science program is definitely only for the hardcore students. If you love mathematics and programming, and this is the right place for you, because you not only know how to use those machine learning tools, you know why you use this one or why you don't that one. Thank you.
Thanks, Dr. Mo, Dr. Tortora. Now we have one last program that we would like to get information from. Dr. Ghosh, if you would like to talk about your program.
Thanks, Rima, for inviting us here. So it's me along with Dr. Main, who's the program director of our school. And so first, I would like to talk about our program. So we are launching a new bachelor's degree course in information science and data analytics, and it will go live in fall 2021. And let me just roll back and tell you about how we can differentiate our program from the many other programs which are being offered in the school or in other schools as well. So first, our program is 100% online, and the entire content will also be delivered asynchronously. So it works for students who are looking for a more flexible timeline. So if you're someone who's already working, or if you're someone who wants a more flexible time for yourself, so you don't have to commute to campus, you don't have to live on campus, but we will record all the course content and it will be made available to you over online. And you could actually go through the lectures over and over again if you want to. And we all know that because of COVID and the entire pandemic situation, most schools are kind of adapting to in this situation, right? So they're trying to move online, and they're delivering all the courses online or adapting to a hybrid system. Now, the good thing about our school is we have won multiple awards on online teaching excellence over the years. So we consider ourselves an expert in online education. So if you're looking for something like that, so yes, you should definitely check out our program. The other thing is, you also have flexibility in terms of selecting the courses, and also you could do it like more, you could actually balance it out with your workload, or if you have a side job, if you're working somewhere, this course is perfect for you. Now, how is our course different from many others which are being offered, right? So we all have seen, like from Anita's slides, we have seen like data analytics, data science means all about those technology components. So you have to learn about the different technology, you have to crunch those numbers, and that's how you arrive at your decision. But we are also looking at things from the perspective of the human in the loop. So we consider 3 important pillars for our program and for all the programs which we offer, because we also do MLIS and MARA. But for all our programs, the important part is combining human, data, and technology, all 3 of them together. So if you look at our bachelor's degree program, you will see that we have various courses like, say, human-centered cybersecurity, or how to include humans, privacy, ethics, and the different human-related components, how you can actually cater to that. So I'm sure you have looked at the COVID-19 data analysis, which is everywhere, also about the election, which is right around the corner. But how does it influence the humans? How does it influence us? How does it influence you? So we also look at those aspects in our program. And also in terms of emerging technologies. So I personally, my focus is on voice-based personal assistant. So I work with systems like Siri, Cortana, those kind of systems. There are people who are working with blockchains and augmented reality. So those are all the emerging technologies. So we will have a course which specializes on those emerging technologies and future trends. And let me think if I'm missing something. So in terms of job prospects, because this is a new program, so what we did is we went out to an independent firm, Hanover Research, and we asked them to take a look into the job market and see how good we should perform in the job market. And it shows that students from our university, from the master's program, and anything which is related to data science, they actually end up earning more than the average California salary. So not only do you have more jobs, but you also have a higher salary in this domain. And our students from the graduate program, they did end up at libraries, government jobs, and different research domains. You could also go to the education industry. And then there's the tech industry in the whole. So you could go to Facebook, Google, if you have those coding skills. And we will be offering courses in Python. We will be offering courses in R. And I remember Anita pulled up one slide and I saw the top one was MapReduce. So we will have a special program. We will have a course in big data analytics. And in that one, we will be covering MapReduce, we'll be covering Hadoop, and all the other latest trends in technology, latest trends in big data and data analytics. So I'm thankful to Rima and the hosts for inviting us here. And if you have any questions, you can reach out to me. You can reach out to Rima, and we will be very happy to fill your questions. Thank you.
Thank you very much, all our panelists, for answering what you do and what your major is going to do for the students and what it is about. I think we do have some questions from the students and that were given on the question and answer. Anita, are you going to be?
Yes, I can facilitate some of these questions. So.
Okay.
I'm so glad we're recording this because I'm taking all of these notes. So thank you all for all of the great insights and opportunities. Now I want to actually become a data scientist, so I'm inspired. One thing that I want to address right away, there's a couple questions about if I'm not gifted in math, should I just give up on this field? Does anyone want to take that one? There's a lot of concerns with the level of math that you might have to be able to complete beyond maybe statistics.
So I can respond for our program, and well, we do require some advanced math. So probably I will encourage not to do the master in data science, because we require like linear algebra, probability, so that probably won't be the best choice.
So I can go ahead for our department. And like I said before, like if you're working with data and if you're doing like hardcore data science, then you will require some levels of mathematics in it, and you will have to be comfortable with math. But then again, if you're looking at those human factors, because there's a very specific methodology called qualitative research, in which you could look at the data and you will look at the data from more a qualitative perspective. So you don't need to crunch those numbers. It's always beneficial to have some mathematical knowledge behind yourself. But if you really want to go ahead with data science, and if you want to look at it from a humanitarian perspective, like you want to go deeper into the data, then again, you can do that as well. And there are certain branches in our program which will allow you to do exactly that. So yes, you don't have to know math, but I would advise that it will be beneficial for you if you know it. Thank you.
Yeah, and with the digital forensics, I think I would kind of echo that. It's you don't have to be really good at math, but you certainly have to be comfortable with numbers and looking at data. If you look at a spreadsheet with a whole bunch of numbers and you get overwhelmed by that, then yeah, that's a bit of a problem. As far as being able to compute things, a lot of times you're working with big data and you use software to compute various things. So you don't need to be able to calculate something by hand, but you should be comfortable with the different techniques and working with big amounts of data and being able to know what kind of analyses to run.
Yeah, I would like to add a few, I would like to make some comments. Yeah, knowing some statistics and mathematics is definitely good, but also there is another aspect of data science where you need to use some tools for data visualization. Like for example, Tableau, or even in, there are some libraries available in Python where after the data is processed, you can use those tools for visualization and creating nice graphical representation of data. For those kind of things, you may not need hardcore mathematics or programming skills. And also you can use the data to make some business decisions after the data is analyzed. So having some domain knowledge in specific fields related to your industry is also very helpful. Just knowing mathematics and statistics is good, but you need to also have domain specific knowledge. If you're working in epidemiology, you need to understand, you need to interpret the results, So that's why it's very important to have specific domain knowledge. I just want to add this to the other speakers,
Yeah, I would just jump in as well and just add to that. I think you don't have to be gifted, but you have to want to understand it. Mm-hmm. Really, we have computer programs doing it, but if it's wrong, if there's a mistake, if you understand numbers, you'll be able to pick it up, like something is not right? Rather than you're just presenting something that makes no sense. I think that basic understanding, even teaching my master's level quantitative methods class, I've had to go back to grade school algebra to cover some things because, when you run a regression, you kind of have to know y equals mx plus b, right? And so it's, you need that foundation. I wouldn't jump into this, one, if you hate math, and then two, if you don't, if you are interested, then you can always learn it. I don't worry about being gifted at something because you can always learn it. But you have to have that interest and understand the connection between what you're seeing on paper and the computer output.
Wonderful. Thank you so much. I have a secondary question that's come in that I think would be really interesting to hear from all of you. How did you actually discover your interest and passion for data analytics? This student says, I'm a little interested, but I'm not sure it's for me. So I think looking for some stories as far as how you discovered this as a passion area.
I enjoy working with numbers. Most departments have struggles finding people to teach statistics and research methods, and I love it. And I can look at a data set and it's about finding patterns. So my background is psychology. So it's not, computer science or data analytics, it's psychology. And for me, it was being able to take all of that information, and I did a lot with scales and personality and all of that. And being able to look at all those numbers and be like, wow, if you put these together, you get this result. And if you put this together, you get this. And what happens if you do this? And what happens if you do this? And so that's why I said you don't necessarily have to be good at math, but you need to be able to work with numbers and data sets and be comfortable with it and actually find it intriguing and exciting. So for me, it would be, do you look at that and do you see a whole bunch of different possibilities? Looking at networks of how people are connected and understanding what that means. If you talk to one person, then they go to someone else, and they go to someone else, and then they talk to someone else, 6 degrees of separation, that kind of stuff, social networks. So that'd be it for me.
I think what I would say is that I'm not I don't really think I'm good at math. I don't really like doing it necessarily, but I like economics. That's what drew me to it. And I like, learning things and discovering things. And so I had to, get comfortable with math and programming. And now when I'm doing empirical work or data analysis, it doesn't feel like math to me. It feels like problem solving. You have to think, why doesn't this code work? And what is it about it? So it's a different part of your brain, I think. And just one last thing, there's something called a growth mindset, which is, an example is, I'm not good at math yet, but I can study it and learn it. And the opposite of that is where you say, I'm just not a math person and I can't do it. And that's the wrong mindset to have, because it is a skill that you can learn. And if you're here on this call and you're a student, I think you have enough confidence in your ability to work with numbers that you probably can do it if you want to. So thank you.
Yeah, I totally agree with Dr. Holian, because if you have the right mentality for it, if you want to learn, I think it's not that hard to learn. As for me, I am a computer scientist, and working with data, working with numbers, that's always which I found myself very attracted to. So I've always been doing that. But I think when I was doing my PhD, I felt that it also gives us an enormous opportunity to apply what we are learning into socially relevant things. So for example, I have used my data analysis skills to develop softwares to prevent cyberbullying, which is happening online. Right now, I'm working with conversational systems to make them more suitable for people with disabilities. And I'm actually teaching a class which is called Problem Solving with Data. And we are looking at large-scale data sets. And in that class, this semester, we are working with COVID-19 data. So we are looking at the data. We are trying to recognize those patterns and how the Twitter feeds were like when COVID initially began, and how it actually has changed over the months. So we are looking at all those aspects. And I think on one hand, it's exploratory, it's very interesting. And on the other hand, you also get to deal with something which is very real, which is happening right in front of you. And you can make those impacts in the society and like to the society, I think. So I think that's really great. And that should really motivate you to be in this area of work. Thank you.
Let me add to this discussion the latter part of the question, which is, a student who is a little bit interested but doesn't know whether that's really for him or her. And my take on that is I would take an introductory business analytics course, for example, and that can be at our university. We have these courses in our department, for example, but it can also be somewhere else online on Coursera or any other of these MOOC sites. And so after taking one of these introductory business analytics or data analytics courses, you will very quickly discover whether that's your path for the future or whether you want to do something else.
Thank you so much. I think a lot of our students now, you're generating more questions, but I think the hopefulness of having enough of an interest in exploring that further with even an introductory course or maybe the data analytics for all seminar, like attending one seminar, can give you a better insight into, is this a good fit for me or not, without making a big commitment or thinking that you have to get a full degree to pursue a career in analytics. If we can get a little bit into some of the mechanics and specificity of the field, some of our students are wanting a definition of the difference between data science and analytics versus areas like management information systems and some other areas that touch on data, but maybe are not doing the analytical pieces.
I probably would just reiterate what, Anita, you said in your opening presentation, that jobs that require these skills go by so many different names, and there's no uniformity, there's no dictionary that everybody's consulting. So as you said, Anita, you really have to dig into the descriptions of them. It's a new area and there's a lot of jargon around it. And basically, I would say it comes down to, we're not settled on the jargon yet.
Yeah, I would like to say that basically data science is an interdisciplinary field. It is about scientific methods, processes, and systems to extract knowledge or insights from data in various forms Either it can be structured or it can be unstructured data. And it's a combination of, intersection of, say, computer science, statistics, and also, some kind of specific domains, in the area. It also needs some algorithm. So it's not just one specific field, it's an interdisciplinary discipline, actually. That is basically data science. And another there is a very interesting comment made by Google's chief economist about data science, is the ability to take data, to be able to understand it, to process it, to extract it, and to extract actually value from it and visualize it and to communicate it. That's going to be a hugely important skill in the next decades. That's all I want to say about the field of data science.
Thank you. Okay, so next question. This for student states, I will be a business analytics graduate in December. Though I've taken courses within my field, I've realized I enjoy data analytics a bit more. As I'm applying to entry-level positions, should I be concerned that my skill set is not concrete? For example, I have knowledge of Python and SQL, but have not completed any certifications. Any opinions on that? So how much experience do you think is necessary in order to get your foot in the door for a new grad?
I personally feel that the certifications it does open the door, but in case if you don't have the certifications, but you know about the different, first thing you should pay attention is to the job call. So when you see an open position, you should look at what they're looking for exactly. And if they want someone who knows those skills, then you should think about if you can really contribute in that position. If you know those skills, and then I feel like even if you don't have those certifications, you could always mention that in your CV. And a good idea is always to mention like your level of experience or expertise in that. So you could always say I'm an intermediate, or I'm an amateur, or I'm an expert in this field. And they will definitely go through your CV. And if they find you the right fit, they will ask you for an interview, and you could prove your skills there, and they will figure it out what they want.
Any other thoughts on that?
Yeah, I agree that the certification is not really necessary, because you will have to pass an interview in which you will be asked to code. So if you are honest and you say, yeah, I'm an intermediate, I think you will totally be able to apply for those positions. Yes, I agree that you should find a good fit, something that is within your possibilities, but it's not necessarily a certification that make a difference.
Yeah, I would like to add that if you're interested in getting a job in data science, start working on some projects and publish those projects in GitHub, so you build a portfolio, and also getting an internship in some companies so you can have some real world experience. So all these will help you to get a job in data science. So even if you don't have any job, you can always go to Kaggle, and there are plenty of data sets available for you. You can start contributing to GitHub, build your portfolio, and when you apply for a job, you can share all those projects that you did, and that will be very helpful for your career.
I just want to add for students that if you missed the earlier presentation, I did share some of the open positions that are now posted on Handshake, which is our job and internship database just for SJSU students. So if you go to the Career Center and click on resources, Handshake will be one of the first resources there. And there are about 130 positions open right now. Of those positions, they're all remote. So especially during COVID, if your concerns are, how am I going to get on site? And what's nice about the analytics piece is a lot of the data analysis and using a lot of the statistical information and coding can be done from home. So that is unique to this field, and they are all paid internships. So if you are interested in those opportunities, please connect with us at the Career Center. All of your career counselors are listed under About Us. You can email us and we'd be happy to walk you through that search, and also how to best present your portfolio and showcase your GitHub as well as Kaggle projects on LinkedIn so that a broader network can get to see some of that work. Are you guys still good for a few more questions? There's a lot coming in right now. Okay. We officially end at 1:15. I just want to let everyone know that, but you guys are interested, and there's about 60 of you here that want more, so we're going to continue. Let's see here. Let me just catch up with some of these questions. There's a lot of concern that if there is a disadvantage to picking one area or discipline because there's so many options now at approaching data analytics from the different disciplines. Do you feel like a student has to pick a specific major or emphasis area for analytics? And in addition to that, the math question before, now a lot of the questions are how much computer science and coding is necessary, and what are the main programming languages students should be focusing on?
I'll touch on the are they different, and my colleagues may disagree with me, but no, they're all very it's saying is computer science and computer engineering different? No, but yes, they are, right? And so a lot of the same foundations are found in all of them. It's just how they're applied. And so obviously, if you have an idea of how you're wanting to apply that knowledge, then yeah, it would be good to focus in business or computer science or forensics or whatever it is. But if you're more open, then no, having those foundational skills and then being able to apply it to different areas can be done. So they're all going to teach very similar foundation. It's just how you apply them.
I'm from the computer science department, but I like to second Bryce just mentioned. It really depends on which layer of the data analytics you want to work on. And certainly, if you really want to know the bottom of the data analytics, certainly that's a totally different story. But if you just want to use the data analytics as a tool, then the acquaintance with the programming is certainly the minimum.
In your disciplines, are you seeing trends in any of the coding languages that you feel students should have some mastery of?
I just wanted to pitch in regarding that question.
Yeah, at this moment, certainly the most popular one is probably Python, and the other one is R. So those are the two top language used in related to the data analytics. But again, it still depends on the domain you like to apply to those techniques.
Thank you.
Just to add a little bit about the programming language, yeah, I agree completely that those are the two programming languages that are most popular right now. One of the things that we try to emphasize when you're learning to program is that it really doesn't matter which programming language you learn. What is more important is to develop this programming mindset in which you learn how to solve a problem, because programming language evolve, and eventually right now Python and other programming languages are hot, but eventually in a few years they're gonna be different. When I learned to program like more than 30 years ago, I learned to program in programming languages that are no longer used. But the idea is not so much to know the syntax of the program in terms of, oh, should I put a period or a colon or something like that, because that changes from a programming language to another. If you learn one programming language and you develop this programming mindset, then you will be able to easily shift from the programming language that you learn right now to the next hot new programming language.
Thank you. That was very helpful. We are, I want to be respectful of time. And I want to thank all of our faculty members and panelists today, a very insightful event. I want to also thank our colleagues for joining us. For those of you, if you joined late, there is, I will ask my colleagues to resubmit the Google form in the chat. And if you fill that out, we will send you a copy of the recording today. If you have follow-up questions, students, please connect directly with our faculty partners. as they have been very open about how you can best connect with them and email them directly. And Rima, is there anything that you would like to add on behalf of academic advising?
First, thank you all for being here, and thank you all for our students for attending this and getting all this information. We as advisors can help direct you to the place you need to go if you have questions. So you're welcome to contact advisors at AARS. You can do live chat at sjsu.edu/AARS, or you could also drop in to meet with our advisors. Our links are on our web page. Yeah, this was a good program.
You sound surprised. Why do you sound surprised? Just kidding. Everyone, if you're looking for the contacts, again, I know sometimes it's hard to see names. I'm going to have this slide here so you can see those who participated. And again, that is the conclusion of our event. If you'd like to give us some feedback, we really value your feedback.